We are the General and Expedition Adventure Research Enterprise. My name is Thomas Draper. I'm a mechanical engineer and serve as the project manager for our team.
My name is Nolan Ruble. I'm also a mechanical engineer and I work on the data acquisition team.
My name is Ryan Paul. I'm a fourth-year mechanical engineering major and I'm on the design sub-team.
And my name is Owen Davis. I'm a mechanical engineering technology major on the fabrication team.
The project our team has been working on this year is called the Stormy Kromer Hat Fitment Project. Stormy Kromer is a fabric company based out of Ironwood, Michigan, and has sponsored our team for this project. The team members involved in this project include all of us presenting here, along with John Elliott Orr, Cal McNabb, Kaylee Elmblad, Jenna Lubon, and Wesley Barron. Our faculty advisor is Dr. Brett Hamlin. Stormy Kromer has hired our team to develop a standard method for measuring hats in their hand-sewn production lines to determine where variation is occurring in the process. They are experiencing quality issues that affect the size of the hats. Our team was challenged with determining a method to quantify hat fitment and develop a device to determine where the variation is occurring in the manufacturing process. Our team began this process by doing extensive research to determine existing methods for measuring hat size. We found that current methods of measuring hat size are not consistent and depend on force. The device seen in Figure 1 is a traditional hat sizing tool. Using this tool, the same hat can be measured at different sizes depending on the force applied to the device. This introduced the first design constraint for the team. The device that we developed needs to measure hats at a consistent force. We were able to develop a device that helps us quantify hat fitment as shown in Figure 2. We used this device last year at the Design Expo and sampled about 50 people to determine the desired force a hat should be worn at. This would give us a value to shoot for to calibrate our constant force measuring device. After some design iterations and brainstorming, we developed a design idea that allowed our team to split up and conquer the challenge. We broke up into a design team to develop the CAD model, a fabrication team to rapid prototype, and a data acquisition team to develop the motor interface and coding. We will go through these teams to showcase our design iterations now.
To start out, the team decided to use a motor to count rotations and torque values once the hat sizing device reaches the inside of the hat. The first design iteration is featured in Figure 3 shown on the Expo poster. This design features a spiral disc in the middle, which allows rounded pieces to expand as the motor spins. This was a very general design iteration, as there is nothing which allows the hat to rest upon or legs to support the device. Iteration 2, seen in Figure 4, shows the addition of legs to support the device and a brim support which allows the Stormy Kromer to rest on the device. The idea was that when the button is pressed, the motor would rotate the spiral disc, allowing the brim support to expand until it reaches a certain torque value, which corresponds to the size of the hat being measured. Iteration 2 was prototyped and small changes were made, such as rounding the brim supports, which are included in Iteration 3, seen in Figure 5. Since this prototype was 3D printed, Iteration 3 faced friction issues, which would not allow the dovetail sliders to function properly. The team decided to incorporate small linear sliders, which were professionally manufactured, to reduce the amount of friction. These sliders are incorporated in Figure 6 on the base plate. Figure 7 shows the final and current iteration of the model, which functions much better with the sliders.
During the rapid prototyping process, the main tool that we wanted to use was the 3D printer. The reason we wanted a 3D printer was because it was a very easy, cheap, and effective way to get a CAD design into the real world and see, analyze based off the integrity, durability of the design, look at the tolerancing, and analyze the functionability and the ease of operator use for a physical part that we had.
The data acquisition team was responsible for developing a system that could measure and display the size of the Stormy Kromer hats using the mechanical system developed by the design team. In order to do this, the team utilized an Arduino microcontroller in conjunction with a DC gear motor and an embedded encoder. By relating motor current draw with torque feedback, the intent was to calibrate the device until a certain resistive force is supplied by the hat being measured. In order to accomplish this, a dual-channel relay is used to measure the voltage drop across a shunt resistor in series with the motor and supply the voltage back into the Arduino for use in control logic of the motor. Once a measurement is recorded, a reset button flips the relays and drives the motor backwards until the encoder count returns to 0 and the device returns to its resting state. In order to avoid signal noise interfering with the encoder measurements, 2 Arduinos are used, one for the control motor and one for the encoder control.
In conclusion, our team was able to design and develop a prototype that can measure hats consistently. As Nolan covered, we ran into troubles with our data acquisition, relating the torque feedback to a constant force, and Nolan will now go over what we plan to do in the future.
The future scope of this project includes production of a final product, including final manufacturing of the design, production of a printed circuit board for the data acquisition system, revision of the user interface for ease of product use, and the implementation of a more robust and accurate force measurement system, as the amperage feedback of the motor does not currently provide calibratable or repeatable results. This could include the implementation of things such as a professionally manufactured torque sensor or force sensors on the use of the broom stops.